Today we're doing Math 6, Mission 1, Lesson 13, polyhedra. Polyhedra is a new word for us. So let's study some examples and non-examples. So these ones right here are polyhedra. Let's see what they look like. Well, they're 3D shapes, definitely. I see that all of them are made up of shapes that are familiar to us. So that's a square, triangle. This is 1, 2, 3, 4, 5. So that's a pentagon, right? Here's another triangle and another triangle. They all seem to have straight lines. So we have 3D, there's shapes, line segments, right? Straight lines, line segments. Let's look at non-representation. This is round. It's still a 3D shape, but it's circular. Again, this is circular. So a circle is still a shape, but it's circular. These are not circular up here. So I would say polyhedra are not circular or round. This has an open section in the middle, and this one doesn't have a top. So it must be a closed shape. Okay, can't have spaces, can't have missing lids or tops. All right, so what features help you distinguish a polyhedra from other figures? Well, they are made from polygons. Right? So that would be like a triangle, a square, a hexagon, a pentagon, right? They do not have unattached edges. No unattached edges. They have no curves, right? That's one thing we put up there, no curves. And it will be a closed shape. So it won't be missing a lid, okay? So polyhedra also have faces. So these are like the flat parts, right? That's a face, faces. It will have an edge. So this is an edge where two faces come together. That's an edge. And then it will also have vertex or vertices, right? Vertex is one, vertices is multiple. That's where you have line segments coming together to make kind of like a point. All right. Here are some polyhedra called prisms. All right. It says, A, look at the prisms. What are their characteristics or features? Okay, so when I look at them, I see that they all have a specific shape that is in all of them. Do you see that? Each one has a rectangle as a face. So they have rectangular faces. I also notice that they have another shape that goes with them. So like in A, it's a triangle. In B, it's a rectangle, a square. C, it's a triangle. D, it's a 1, 2, 3, 4, 5 pentagon. F is a 1, 2, 3, 4, 5, 6 hexagon, right? So they have, many of them have two faces that are different are a set, a pair of different polygons. So you can see we have a triangle and a triangle, and they're across from each other. Do you see that? Triangle, triangle. Here, down at the base here, we have a pentagon. Down at the base here, we have a hexagon. So those shapes, those different shapes are opposite of each other, right? So E, you have rectangular sides, but then your top and your bottom are squares. All right, let's look at pyramids. There's some polyhedras called pyramids, right? And so if I look here, we can see a very common shape. Just like up here, we had the common shape of rectangles, right? Down here, we have the common shape of triangles. So do you see that? Triangle, 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 right? So they all have triangles. But what's different from the prism to the pyramid is every side is a triangle except for the base. So all sides are triangles except for the base. So you can see down here, this base is a triangle, so it can be a triangle for a base, but this one is a square. This one is a 1, 2, 3, 4, 5 pentagon. This one is a hexagon, I bet. Yep, hexagon. So we can also say, do you notice that all of the triangle faces come to a point? So the triangles meet in a single vertex or point. That's the characteristics of a pyramid. Okay? So for your reference, this net can be folded into a pyramid, right? So this line is going to meet up with this line, right? No, I'm sorry, that's wrong. Let's look. This line and this line are going to meet as are that. So that's going to get us our triangular base. And then these are going to meet right here to give our point at the top, right? These two are going to come together to make our point. So it's going to look like this. This one, again, this one, and this one are going to come up to a point, and it's going to go out like that, right? Let me try that one more time. It's going to go like this, and then it's going to go out and out and out to make that pyramid. This one, however, this is the top. This is going to look like this. So these two are going to come together. These two line segments are going to come together. But what's going to happen is it's going to look like this, right? Whoa. Hate when it jumps on me. So sorry. I never know when that's going to happen either. It just likes to jump. All right. You can go back and pause if you are still writing the pyramid section. But for this net right here, a net is a 2D representation of a 3D object. Okay? So we have this point here. This point is going to look like this. And then this has 1, 2, 3, 4 sides. So that one should, net 3, should look like pyramid Q. But it's not going to because it's going to look like this, but it's missing a bottom. So this is not going to work. It would end up looking like pyramid Q, but it's supposed to be pyramid P. So net 1 and net 2 work. And then this one would work if it had like that off to the side. Okay? And it wouldn't even be there. It would have to be like this. There we go. All right. You will be assigned a polyhedron. Decide which polygons are needed to compose your assigned polyhedron. So we're going to go back up here. One more time. All right, so for A, you would need 2 triangles and 1, 2, 3 rectangles to make A. For B, you would need 1, 2, 3, 4, 5, 6 squares. For C, you would need 2 triangles, 1, 2, and then you need 1, 2, 3 rectangles. For D, you would need 2 pentagons, because you have the top and the bottom. 2, 1, 2, 3, 4, 5 pentagons, and then 1, 2, 3, 4, 5 rectangles. For E, you would need 2 squares and 4 rectangles for the sides. For F, you would need 2 hexagons, and you would need 6 rectangles. For P, you would need 4 triangles. For Q, you would need 4 triangles and 1 square, because you have 1, 2, 3, 4, plus the bottom, which is a square. You would need the bottom 1, 2, 3, 4, 5. So you need a pentagon. You would only need one of those, though. One of those. And you need 1, 2, 3, 4, 5 triangles. And here you would need 1 hexagon and 6 triangles. Do you see how the number of sides on the shape is however many triangles you need for pyramids? Pretty cool. All right, so we're going to choose one of the polyhedrons up here. So I'm going to choose S. So that is a octagonal pyramid, right? So if I were going to cut it out into a net, it would look like this. I would have this octagon here, right? Because I only need one octagon, and then I need 6 triangles. So then it would look like this. Whoa. Let's try that again. Look like this, like this, like this, like this, there, there. And so when I put all of these, if I fold along the lines, these all would come together and create a point in the middle there. All right, that is our lesson for today.